Okay, welcome back. In this trig video, we are going to look specifically at the different types of identities and being able to simplify or combine our trigonometric functions. So we are going to look at what are called the Pythagorean identities, and then we're also going to look at the sum and difference. First of all, we have to remember and always go back to your basic identities. So when we're talking about identities, we are talking about the idea of being able to take something and rewrite it in a different way that helps us solve or simplify. So the basic identities we have to remember is we have to remember things like when we have the sine of x, we can always rewrite that to be 1 over the cosecant of x. And so on and so forth the whole way. Cosine of x is 1 over secant. Tangent is 1 over cotangent. Tangent can also be written as sine over cosine. Okay? We can reverse the process. Cosecant can be the same as 1 over sine. Secant, 1 over cosine. Cotangent, 1 over tangent. Or cosine over sine. Now the other piece we have to take into account is the fact that what happens if we have a negative x. So this negative value we apply mostly to your major 3. So the sine of negative x is negative sine of x. The sine of, or the cosine of negative x is the cosine of x. The tangent of negative x is negative tangent of x. So these 3 rules are going to come in handy, especially if we have the negative. Okay? Now those are just the basic identities. We also have to look at identities through the idea of even and odd. So again, the rule of even or odd says that you plug in a negative and you look at what comes out. So here, the sine of negative x comes out as a negative sine of x, which is the opposite. That also means that your cosecant should come out as the negative cosecant because it is the opposite of your sine. Okay? Your cosine and secant then should both come out to be positive, okay, because the secant is the opposite of cosine. So if you notice, when we evaluate, we get the positive. And then we're back again to your tangent. So cotangent and tangent should again come out to be the opposites of each other, and they come out to be the negative. Now the last thing we have to keep in mind is our cofunction identities, because if you say c sine of pi over 2 minus x in your problem, you can rewrite that as the cosine of x. So these cofunction identities can also help you reduce and simplify your problems down. So this whole page, these 3 ideas, is something that you would definitely want to keep beside you as a roadmap as you try and work to simplify and solve identity problems. Okay? Now with that, we have to remember some important information. So first, if we start with your Pythagorean identities, the identity is built off of the unit circle. So we know Pythagorean's theorem to be a squared plus b squared equals c squared. But when we're talking about trig identities and we're referencing the unit circle, we have to rewrite Pythagorean's theorem to be x squared plus y squared equals your radius squared. Okay? Now, we need to remember again that x is your cosine and y is your sine. So if we replace those 2 ideas into my Pythagorean identity, we would also have that the sine squared of x plus the cosine squared of y, or of x, sorry, is equal to 1. Okay? Hang on, let me make that change here. I don't know about you, but I would be a little bit confused if I saw the scribbles. So again, here this should be squared of x. Okay, so sine squared plus cosine squared equals 1. And the reason for that is because the radius of your unit circle is always and forever going to be 1. Now we have some variations of this identity, okay, which say that 1 plus the cotangent squared equals the cosecant. So essentially what we're doing is you are dividing out by your sine or cosine, and you're left with these identities. So I like to call these identities fact. So you have your big one, sine squared plus cosine squared equals 1. But then we can manipulate them simply by dividing or subtracting out your identities to get 1 plus the cotangent squared to be your cosecant, 1 plus the tangent squared to be your secant. Okay, so we have these 3 identities here that you need to remember. Now, in most of your problems, you are going to be asked to either simplify or solve. So here, what you need to do is we want to follow the directions to simplify each trig expression. So we're given an expression here, and you want to simplify it as far as you can go. Well, the way you do that is by manipulating the pieces in this equation in order to reduce it down. So, as a hint, you need to write things in terms of sine and cosine, okay, or look for different identities in order to make things smaller. So here, the first thing that I would do is I would distribute my tangent into my parentheses here, the same as I would do if I was working with algebra. So this is going to become the tangent of x cosine of x minus the tangent of x cosecant of x. Now, one of the reasons I do this is because I want to try and cancel things out. So I know tangent has its own identities. So if we come back here and we look, tangent can be written as 1 over cotangent or sine over cosine. Okay? So with that being said, I have a cosine here, so I would write my tangent as sine of x over the cosine of x, which is still times your cosine of x. And then here I have a cosecant, so I would still write my tangent as sine of x over the cosine of x because my cosecant can be rewritten. If we look again at your identity, the cosecant can be 1 over sine. So if I rewrite my cosecant here as 1 over the sine of x, what you should notice is that I can do some canceling. I've got cosine top to bottom, and I have sine top to bottom. So when I do that, what's going to be left is I'm going to have sine of x minus 1 over the cosine of x. However, we know that that can be rewritten. Again, my 1 over cosine of x is the secant. So here, this is really the sine of x minus the secant of x. And this would be a more simplified version from what we started with. Now, what you're going to have to get used to when dealing with trig functions is that your simplified version might not look any nicer than what you started with. However, what we did was we manipulated our equation here in order to reduce it down. And this is all that you would be asked to do. We're not evaluating, we're not doing anything else special. We are just simply rewriting our equation in a different form. Okay. So let's look at another example here. So I have 1 plus the tangent squared. So this is the same as in algebra. Whenever you have 2 binomials squared, remember you have to FOIL. So what we really have here is we have 1 plus the tangent of x times 1 plus your tangent of x. So we have to FOIL this out. So remember, FOIL is first, outer, inner, last. So we have 1 times 1 is 1. Then I'm going to have tangent of x plus the tangent of x. So this becomes 2 tangent of x. And then this becomes plus the tangent squared of x. Now, if you look closely, I have 1 plus tangent squared of x. So let's rewrite this a little bit here. So I've got 2 tangent of x plus 1 plus tangent squared of x. Now again, from the beginning, if you remember, we had these Pythagorean identities, and one of them was 1 plus tangent squared of x, and we said that's the same as secant squared. So here I have 1 plus tangent squared of x. So this is actually the same as secant squared of x. So my overall result here is going to be 2 tangent of x plus secant squared of x. And this is what we were looking for, the simplified version of 1 plus tangent x squared. Okay, let's do it again. I have 1 over tangent squared of theta plus 1. Well, we just did that. 1 plus the tangent squared of theta, we just set up here, was the same as secant squared. So here, this is going to become 1 over secant squared of theta. But we know 1 over secant squared of theta. Well, what we know is that we know 1 over the secant of theta is equal to the cosine of theta. Therefore, it would make sense that 1 over secant squared has got to be the same as 1 over the cosine squared. And that is what we wanted. Let's look at another. Here, I need to factor and simplify. So I have 4 sine squared y minus 8 sine y plus 4. So the first thing I need to note is that I have a greatest common factor here, which is 4. So anytime you have a greatest common factor, you have to pull it out. So pull out the 4, and what's left is going to be sine squared of y minus 2 sine of y plus 1. Well, if I look at it, this part in here, you are going to factor the same as a quadratic. So what that means is, if I were to look at this through the lens of y squared minus 2y plus 1, we know that we would factor these into its pieces. Where we would factor this into y and y. My back term is positive, my middle term is negative, so I have subtract. And then I need factors of 1, which are 1 and 1. And so if you look at this, y and y is y squared, negative and negative is negative 2y plus 1. So this would be our factor. Well, in order to do this, the only thing that's different is we have this sine piece. So instead of this being y squared, this would have been sine. So what happens is, once you factor it down, we would say that this was the same as y minus 1 squared. So we use that same idea here with our sine. So in other words, this is going to be 4 times the sine of y minus 1 squared. Okay, because the idea follows. So instead of this being y's, again, this would be sine. So you'd have sine squared minus 2 sine plus 1 would factor into sine minus 1 and sine minus 1. Okay. And so this would be your simplified factored form. Okay, let's look at another. Here again we want to factor and we want to simplify. So if you notice, here I do not have a common GCF. Okay, so again, if I simply let cosine equal x, then I can rewrite this problem to say 2x squared plus x minus 3. And so this is what we're going to simplify. So you can always interchange back to algebra, just don't forget what we did in the beginning. So again, here I can reduce this down. So 2x squared is going to break into a 2x and an x. When I'm looking at factors of 3, I have 1 and 3. So I need a factor that's going to give me 1 as a result. Okay, so I'm going to want to put my 3 right here and a 1 right here. And because I want my 1 to be positive, I'm going to add here and subtract. So if you were to multiply this back out, 2x and x is 2x squared. 2x and negative 1 is a negative 2x, plus 3x is 1, and then 3 times negative 1 is negative 3. Now, we've already got our bubbles, however, we just have to remember in the beginning we interchanged out the cosine. So this is really going to become 2 cosine of x plus 3 times the cosine of x minus 1. And this is your factored form. So what you can see out of this one, and even the one prior, is that we can take any trig function, and in order to factor it, we can rewrite it in algebraic terms. Just don't forget that's what you did in the very beginning. Okay. Alright, now let's look at something that's slightly more challenging. So if we look here, I have 30 sine cubed of x, cosine of x over 6 cosine squared sine of x. Okay. So first and foremost, you kind of want to break this apart. So what do we really have here? I really have 30 over 6 times sine cubed of x over the sine of x times the cosine of x over the cosine squared of x. Now I can look at these as 3 individual fractions. So when I look at this, 30 over 6, I know both of these reduced gives me 5 on top, 1 on the bottom. When I look at sine, I have 3 of these on the top, 1 on the bottom. So the sine on the bottom goes away, my 3 can change to a 2. Same with my cosine. I have 1 on top and 2 on the bottom, so the cosine on top goes away and changes this to 1. So if we rewrite your fractions, I have 5 sine squared of x all over the cosine of x. Now once we do it like this, I still need to simplify. So one of the things that I would do is I would rewrite this to say that I have 5 sine of x, and of course we know this is all over the cosine of x. If you look right here, you can see I have sine over cosine, which we know this would be translated into tangent of x. So what I really have is I have 5 sine of x tangent of x. And this is my simplified result. Okay, so if you notice in this one, we had a few more additional steps we had to do, but a lot of it came from recognizing that we could rewrite this or split this up into the individual fractions in order to reduce things down. Alright, let's look at another one. So here I have 5 cosine of theta over the sine squared, and then I have sine squared minus sine cosine, and I have sine squared minus cosine squared. So I have to start trying to reduce some of this. First, I'm going to leave my initial fraction alone. So this is going to be 5 cosine of theta over the sine squared of theta. And instead, I'm going to look at my second fractions and see what I can do. In the top here, I can pull a sine out. So this, if I pull out a sine, what's left is going to be sine of theta minus the cosine. On the bottom, I have sine squared minus cosine squared, which is a difference of squares. So I know that I can actually write this in a factored form that says sine of theta plus the cosine of theta, and then I have sine of theta minus the cosine of theta. Immediately, one of the things you should notice is that I can get rid of those two right there. And so this is going to become 5 cosine of theta all over. Sine squared can be sine of theta times the sine of theta. And I'm multiplying this by your sine over sine of theta plus the cosine of theta. Now if you look, we can do a little bit of canceling again, because notice I have a sine on top and a sine on bottom, so one of these can go away. And so here I am left with 5 cosine of theta over the sine, and I'm multiplying this by 1 over the sine of theta plus the cosine. We have one more simplification that we can do, and it's right here. If you look closely, cosine over sine is the opposite, so this can reduce down to the cotangent. So overall, we end up with 5 cotangent of theta all over the sine of theta plus the cosine of theta. And this is your simplified reduced form. Okay, so again, if you notice, we had to do a little bit of splitting and reducing, and it just simply came with being able to recognize where we are able to factor and remembering what your basic trig functions can reduce to. Alright, let's try one more here, a little bit more complicated. The first thing that you need to notice is that I have this big old subtraction between here. So this is something that I need to remember as you go through and work the problem. Okay, so first of all, I can take this first piece here and I can factor it. So this again is a difference of squares, so we know that this is going to be 1 over, and I'm going to have the sine of y plus the cosine of y times the sine of y minus the cosine of y. And I am subtracting. And over on this other side, I have 2 over, and I'm going to rewrite these so that my sign is first. So this is going to be negative sine of y plus the cosine of y. Okay. Now that may seem a little funny, but you're going to see how this works here in just a second. So on this first one, I don't have anything to do. So I'm going to rewrite it as is so that I can work on the other side. So again, this is still the sine of y plus my cosine of y times my sine of y minus my cosine of y. And then I still have the minus here, and it's 2 on top. But notice negative sine plus cosine is very similar to one of my denominators here. So I'm going to pull out a -1, which is going to change this to being sine of y minus the cosine of y. So I hope you're starting to see what we're trying to do. Okay, what we're trying to do here is we're trying to make common denominators. Okay, because if you add or subtract fractions, what's the rule? You need a common denominator. So we're trying to make that. So when I pull out this negative, I have minus a negative. So this means I can rewrite my initial. So I've got the sine of y plus the cosine times your sine minus the cosine. I'm now changing my sign to addition, and this becomes 2 over the sine of y minus the cosine of y. So if you look at these two fractions, we have to identify that least common denominator. So my least common denominator here has to be the sine of y plus the cosine times your sine minus the cosine. So if you notice, my first term has my least common denominator, but my second term is missing this plus part. So I am actually going to have 1 plus 2 times the sine of y plus the cosine of y, and the whole thing is over that common denominator, which is the sine of y plus the cosine of y times the sine of minus the cosine. And in this case, there really isn't a whole lot more that can be done. The only thing that could be done is we can distribute this 2 through, thus making it 1 plus 2 sine of y plus 2 cosine of y all over that common denominator, sine of y plus the cosine of y times the sine of y minus the cosine of y. So if you remember from algebra, when we do combining rational equations, which is what this is a glorified rational using trig. The idea is to combine them together, and that is what we have done. And since there's nothing else here we can do to try and simplify this further, this would be your overall final result. Alright, so in a nutshell, that is everything that you would need to know to get yourself started with being able to combine and simplify trig functions using the different trig identities. So if you have any questions, please let me know. If you feel like you need to see some additional examples or are still struggling with the concept, let me know that too, and I would be more than happy to work out some more examples for you. Otherwise, I hope you had as much fun as I did, and I will see you next time.